Welcome to an example of finding the domain of a function. Write your answer in interval notation. Now it's writing this kind of funny here. Let me write it out in more typical notation. That's 1 over the square root of 7x minus 9. That's what it's saying. It'll probably look better when you see it on the computer. Okay, so how do we find the domain of that? Well, let me come over here and be clear for you what domain is. Domain is allowable inputs. So domain or x values. Domain is what your x is allowed to be. So then there's two situations we watch out for. We say denominators cannot equal 0. So if we have a denominator, we set it not equal to 0, and we solve. Why? Because you can't have 0 on the bottom of a fraction. Do you remember that? Like, think about fractions for just a minute. What is 10 divided by 2? Now, you know that's 5, right? Because a fraction means divide, and 2 goes into 10 5 times. What about if you put 0 in the top? Well, how many times does 2 go into 0? Well, 0 times. Or 0 divided into 2 pieces is 0. Either way, that's great. But now, what if we put the 0 on the bottom? Again, it's bottom into top. How many times does 0 go into 2? Well, it goes in forever. It's infinity. So in our calculator, it's an error. It's not a number. That's why we can't have 0 in the bottom of a fraction, because it's infinity. It's an error. 0 in the top of a fraction is no problem. That's just 0. But 0 in the bottom, that's an error. That's infinity. So we never let the denominators equal 0. If we have a denominator, we say, hey, denominator, you're not allowed to equal 0, and then we solve for that situation. Now, there's a second case that we have to restrict. Again, domain is what we're allowed to do, kind of like with a microwave oven. You're allowed to put certain things in a microwave oven and certain things you're not. You're not allowed to put in tinfoil or any metal because it'll mess it up. Well, that's what domain is. It's saying, what are you allowed to plug in? And we're getting at it by saying what you're not allowed to plug in. Just like you're not allowed to put metal in a microwave, you're not allowed to make denominators 0 for functions. And the second thing is if you have a square root, a 2 root, the inside of a square root, the inside cannot be negative. Why not? Well, what's the square root of a negative number? Think about square root of 9 for a minute. That's 3. Because 3 times 3 is 9. That you know. What's the square root of negative 9? It's nothing. You cannot do it, right? Because negative 3 times negative 3, that wouldn't work. That'd be positive 9. So you can't do a negative in a square root. So if we have a 2 root, a square root, the inside, we cannot allow that to be negative. So we say inside, how do you say mathematically not negative? Well, positive or 0, right? That's what not negative means. It means it is positive or it's 0, thus not negative. How do you write that? Greater than or equal to 0, right? Greater than is positive and equal is 0. It's greater than 0, which is positive, or it's equal to 0. So and then we solve it. Let's go dot, dot, dot. So that's the second situation. So we look for those two situations with for domain. Whenever they ask us domain, they're asking us what's allowed, what are the allowable x values. If we have denominators, we say denominators can't be 0, and we solve. If we have a 2 root, a square root, we say the inside has to be greater than or equal to 0, positive or 0, not negative, and we solve. Now, let's get to our actual question. Here, we have both situations. This is a square root. So first off, we say, oh, it's a square root. So we say the inside of a square root has to be greater than or equal to 0. So 7x minus 9, the inside there, has to be greater than or equal to 0. But it's also in a denominator. It's both in a square root and in a denominator. So it cannot equal 0, so get rid of that little equals, right? That line underneath the greater than symbol means equals, greater than or equal. So we say 7x minus 9 is just greater than 0. You could write that as a third condition over here if you want. You could say, look, third condition, if you have a square root, if you have whatever, blah, blah, blah over the square root and you have the inside of a square root in the denominator, you take out that inside and you say, hey, inside, you have to be just greater than 0, and then you solve. Because it's in the denominator, so it can't be equal to 0. And it's in a root, so it can't be negative. It's greater than only, greater than 0. So let's solve this. Let's add 9 to both sides. Cancels this out. And so we get 7x greater than 9. Last step, divide by 7. Boom, there it is. X has got to be greater than 9/7. So let's bring that up here. So our answer is, oh, and they say interval notation. So how do you write that in interval notation? Well, might be easiest to put it on a number line first and say, all right, here's 9/7, and we want the x is what? Greater. He's on the wide side of the symbol. Greater stuff is to the what? To the left or the right? You know it's to the right, huh? So x is greater. So x is over here. X is to the right of 9/7. So this is going to be a parenthesis, not a bracket, because there's no equals bar. So it's, and it goes to infinity, doesn't it? So we're saying any number greater than 9/7, any number from 9/7 up to infinity. So the answer in interval notation is 9/7 to infinity, parentheses on both. That's the domain for that function. There we go.